very carefully to what David said about the fact that we were using the string to draw the ellipse. Okay. We have a smooth curve graph in which every point sum of the distances to the two focus points is constant. And that is modeled by our string activity, also pictured here on the board. We're moving our pencil around to draw the round shape, always using the same piece of string, which is always the same length, so those two pieces are always going to add up to the same number. We have standard form equations for an ellipse. I'm going to give you some time to jot this down, and then we'll talk about everything. Okay, so as you're kind of finishing up writing, let's just look really quickly up at those standard form equations for the ellipse. They're very similar to each other. Okay, what is really the only difference between the two equations for a horizontal major axis and a vertical major axis? Where the a squared and the b squared are, right? Okay, so then we're going to come up with this whole issue. A, B, H, K, those are all going to be numbers for a specific ellipse. So when we're looking at an equation, if a squared and b squared are both represented by numbers, how will we ever know which one a squared is? That's where the next statement comes in. A squared is always the bigger number. So you're always going to have these numbers in the denominator, and in order to decide which one is a squared and which one is b squared, you look for the bigger number. Okay, the bigger number is always your a squared. To determine your major axis, if your bigger number, your a squared, is underneath the x, then you have horizontal major axis because x is horizontal. Okay. If your bigger number, your a squared, is underneath the y, then you have vertical major axis because the bigger value is paired with y, which goes up and down. Okay. So all of these things are interconnected, and that vertical and horizontal major axis are dependent on where is the bigger number. Is it underneath the x or underneath the y? HK has changed a little bit here. Back in our parabola, HK was representative of the vertex of our parabola, and if you'll remember from graphing that assignment on page 700, the vertex is actually a point on the parabola. Okay, so we would draw a line through the HK. Now, for ellipses and hyperbolas, HK is like the HK for a circle. It's a center point, count out from that point, but it's not actually on the ellipse or on the hyperbola. Okay, just like the center point is not on the circle. Okay. And then there are three other pieces, A's, B's, and C's. A is the distance from the center to a vertex. Okay. Now, if you have a horizontal major axis, and your bigger number is underneath your x, then when you count A from your center point, you should count left and right. If A is underneath your y, so that you have a vertical major axis, then you'll count up and down for A. And then B is the distance from the center to a covertex. Okay. That would be in the other direction. It would be on what we call like the minor axis, okay, the shorter axis of the ellipse. And if you're on a horizontal major axis, then B is paired with y, so you count up and down. If you're in a vertical major axis, then B is paired with x, so you count left and right B. So how will you know what direction to count those values, A and B? Based on what coordinate it's under. Is it under x or is it under y? Now, there is a C. C is the distance from the center to the focus. And just like on the parabola, we had a focus and a directrix, which weren't on the parabola, but we wanted to include in our graph, and you should be able to label. The same thing's going to be true for our ellipse. I'm going to want you to be able to tell me where the two focus points are. Okay. So C is the distance from a vertex to a focus, and one thing you could add here, A and C are both on the major axis. Okay. A and C are always on the major axis. So if you have a horizontal major axis, A is paired with X, then you count left and right A, you also count left and right C. I sometimes tell students, A and C are always friends. They always go on the same line. B is the only one that's the oddball. It has to go in the other direction. Okay. The big question is, what the heck is C, right? How will we find that distance? In order to determine the value of C, we're going to use a statement that looks very similar to the Pythagorean theorem, but be very careful in the ellipse. Make sure you write this down correctly. It is not the same as the Pythagorean theorem because it's c squared equals a squared minus b squared. And that's just because of like the way we're labeling A's and B's on the ellipse. If you were to do an in-depth investigation with some triangles, you would uncover basically the Pythagorean theorem, but then the A's and B's and C's would be switched around. We don't have time to do that, the proof of why that is c squared equals a squared minus b squared, but certainly that's something you could look into if you're interested. Okay. Next up, we have one other thing that we want to talk about. It's called eccentricity. Okay. Eccentricity will measure the ovalness of an ellipse. And eccentricity we usually just call E. So here we're not talking about the number E, we're using E for eccentricity. E is equal to C divided by A. So the distance from the center to the focus divided by the distance of the center to the vertex. Now, in order for this shape to be an ellipse, C over A must be somewhere in between 0 and 1. If C over A is equal to 1, that would actually be a circle. The distance from the center to the focus, the distance from the center to the vertex are the same. That would be a circle. And so you can think about like eccentricity, the closer those are, the more round they are. And then the further apart, the more oval it's going to look. Okay, that's just a ratio. Okay, let's do an example. We are going to work with this equation, quantity x minus 2 squared over 81 plus quantity y plus 4 squared over 36 equals 1. And we want to find the center, vertices, foci, eccentricity of the ellipse, and then sketch the ellipse. Okay, so kind of here's how I graph an ellipse. This is my method. You can go out of order from what I like to do, but I'm going to say this before I get started. I really do it a lot like I did a parabola, which is graph some things like my HK and then count out from HK. So I count it out to my focus and I count it out to my directrix, and then I label things. So it's kind of the same thing I do with ellipses and hyperbolas. So I'm going to go ahead and try to identify one thing, one place to start. A great place to start is always my center point. So I'm just going to look at my equation. What is my center point? 2, negative 4. Excellent. Thank you. 2, negative 4. So I'm going to go ahead and graph that point. Okay, that is the center of the ellipse. It's going to be a really important point. I'm going to count out for it to get my A, B, and C, my vertex, co-vertices, and focus. So I'm going to go ahead and plot 2, negative 4. And I'm going to label that center. Sometimes I label my points only because if you have too many points plotted, you might forget what's what. Okay, now the next thing I do in my equation of an ellipse, if it's in standard form, is I just go ahead and I try to look for, like, okay, what's a squared? Which number up there is a squared? 81. Because it's bigger. Okay. A squared is 81, so that means that A is equal to 9. And then, of course, B squared is 36. Right. So B is equal to 6. Excellent. And what I'll do is I'll just go ahead and plot those. Those are going to be my vertices and my co-vertices. They're going to be like the outmost points of the oval shape. And if I connect those 4 points with a round shape, then I'll have my ellipse. So after I identify A is 9 and B is 6, then I try to match up like what coordinate is it with. So what direction am I going to count in those units? So A is paired with X. Since A is 9, I should count left and right 9 to get to my vertex. So I'm going to count left and right because it's paired with X. And there's a vertex. And I got to go the other direction. 1, 2. There's another vertex. Now, I may ask you, like on your quiz on Wednesday, and you should practice this in your homework, like identify where the vertices actually are. So now I'm going to label those as ordered pairs. So I have one vertex. I was at 2, -4, and then I counted right 9. So now I'm at 11, -4. And then I was at 2, -4, and I counted left 9, so now I'm at -7, -4. So this part about labeling the points, like this should be very basic. You're just counting distances, left, right, or up, down. Okay, so don't make that any harder than it needs to be, right? You add and subtract the A value. I'm also going to do my B's, which are B is equal to 6, but B is paired with Y, so I should count up and down. Okay, so I'm going to count up 6. That's a co-vertice, and I'm going to count down 6. That's another co-vertice. On these, because I'm counting up and down, my Y value is going to change, but my X is always going to be 2. So I'm going to be at 2, 2, and 2, -10. Because I'm adding 6 to my Y value, -4, and I'm subtracting 6 from my Y value, -4. I usually like to, at that point, once I get those 4, the co-vertices and the vertices, I like to draw my ellipse. And I'm just thinking in my head, just like I did for those polar graphs, round, 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 try to draw it round. Okay. It's an ellipse, not a diamond. Oh, that side was too round. It's like Hey Arnold's head, I think. Anybody knows that show? Or what? Oh, yeah, it does. Okay. Make some art with that. Okay, so try your very best. Mine is not very good. Okay. The other thing, though, that I'm going to be checking for is, of course, your foci. Right? So, like in the parabola, we had focus and directrix. I want to see where your foci are so that you can start to make the connection, like when the foci are further apart, when the foci are closer together. Those types of things. So we've got to find out what C is in order to find our foci. In order to find C, we got to use that thing that looks similar to, but is not the same as with the Pythagorean theorem. C squared equals A squared minus B squared. And you already know what A squared is, 81. B squared is 36. So C squared is equal to 45. And then I would take the square root of both sides. Now, for the actual value of C, when you're giving me the foci points over here, I want it to be exact. So I would simplify the square root of 45, which is 3 square root 5. To put it on the graph, I don't really know how to count 3 square root 5. You probably, for graphing purposes, want to estimate where the square root of 45 is. Okay. So I think about it like it's between the square root of 36 and the square root of 49. So it's between 6 and 7. Could you type it into a calculator and get a more accurate answer, like 6.71? Could you get a more accurate answer? Yeah, am I going to be able to tell the difference between 6.5 and 6.71 when you graph it? No, I'm just going to look to make sure that you did it. You put a focus point somewhere in between 6 and 7 away from the center point. Okay, so I'm not going to be like super crazy about that, right? So we're going to say it's about 6.7, okay? And then you would just add that to your graph. So from the center point, I would count 1, 2, 3, 4, 5, 6, and then some. There's the focus. And then I'll count left. 1, 2, 3, 4, 5, 6, and then some. When I give you like a quiz or a test, you're going to have like a coordinate plane, so I'll be able to actually check that you're between the right unit. On your homework, you're just kind of like estimating it if you're drawing your own. And so then when you list those out as ordered pairs, they're more like the vertex points where we were counting left and right. So we're going to have to add that perfect or that exact value, 3 square root 5, to my 2. So one of my focus points is at 2 plus 3 square root 5, comma negative 4. And the other one is at 2 minus 3 square root 5, comma negative 4. So on that, I'm going to be picky. I'm going to say I want the exact location of the focus point. Okay, so add, subtract, the simplified radical. Don't give me like 2 plus 6.71. I don't want that decimal value. Okay. Last thing that we want is eccentricity. And that's a pretty easy one. Eccentricity is just C over A, correct? Mm-hmm. So my C was 3 square root 5. My A was 9. Please make sure it's simplified. That would be square root 5 over 3. If you think about the square root of 5, that's between the square root of 4 and the square root of 9. So it's between 2 and 3. If you have a number between 2 and 3 divided by 3, it's probably pretty close to 1. And when you look at your graph, you can see eccentricity, the ovalness. As it gets closer to 1, it looks more like a circle. It's less oval. And when it's closer to 0, it's more oval. Does anybody have any questions about my methods for graphing there? Okay, the next example that we at least want to look at before we leave, we've got about 5 minutes, is one where it's not given to you in standard form. So we have the same directions here. Find the center, vertices, foci, eccentricity of the ellipse, sketch the ellipse. I also always find the co-vertices. I can't remember if that's included on the quiz or not. I can tell you tomorrow. But I always find those too because you do it anyway to graph it. But looking at this equation, 4x squared plus y squared minus 8x minus 4y plus 4 equals 0, I can't tell you what h and k are. I can't tell you what a squared and b squared are. Like, it doesn't look like one of those forms. So I've got to adjust. And just like we did for the parabola, we're going to need to complete squares. Okay, because when you look back at the equations for the ellipse, you've got the x minus h squared, you've got the y minus k squared, so we need to complete the square for x's and for y's so that we can have that same look and identify our center point. So here's what I would say. If there's a number that does not have x or y, move it to the other side. So I'm going to subtract 4. On the other side, where you have all the x's and all the y's, group them together. So I'm just going to rearrange. 4x squared minus 8x plus y squared minus 4y. Now, remember back from chapter 2 in semester 1. In order to be able to complete the square for something like 4x squared minus 8x, the leading coefficient to your x squared term must be 1. Since you have a 4 in front of x squared, you're going to have to factor that out before you complete the square. So we have x squared minus, and if we factor out 4 from the x squared, we have to factor out 4 from our x term, which is going to leave us with minus 2x. I'm going to leave some space to complete the square and then close my parentheses. I will complete the square in that group of parentheses where I have factored out 4. For y, I really don't have that issue. Okay, so I can just write plus y squared minus 4y. I am going to have to complete the square right there. I'm going to leave a little blank, and then it equals negative 4. Okay, so now with ellipses and hyperbolas, you're going to have to complete the square twice. Go to your middle term. Half of negative 2 is negative 1, squared is 1 completes the square. What did you really do right there? You really added 4 on the left side of your equation. So what do you have to do on the right side? Also add 4. This was a really hard thing for a lot of people back in semester 1, chapter 2. What question do you have? Why? Okay, when you complete the square root plus 1, are you okay with that? You didn't really add 1, you added 4. Now, what completes the square over here? Half of negative 4 squared? 4. Okay, so I'm going to put a plus 4 right here. And then if I added 4 right there, add 4 on the other side. So now I'm going to keep my 4. This can be rewritten as x minus 1 squared plus y minus 2 squared. I'm factoring my perfect square trinomials. And then negative 4 plus 4 plus 4 is 4.
Why did you add another 4 with the y squared?
Because I put a plus, this green 4 wasn't there originally. So I just weighed down this side by adding 4. I have to add 4 on the other side. Golden rule of algebra. What I do to one side, I have to do to the other. So when you complete the square twice, you're going to add 2 things on the other side. Okay. Now, this looks closer to standard form. The last thing I have to do is make sure that it's equal to 1. So I'm going to divide everything by 4. So that gives me x minus 1 squared over 4 plus y minus 2 squared. Oh, sorry. X minus 1 squared. The 4's cancel, right? Plus y minus 2 squared over 4 equals 1. Could you now start that whole process? Like, do you know what the center is? 1, 2. Do you know what the a value is? Well, a squared is 4, so a is 2. Do you know what the b value is? 1. B squared must be 1. Could you find c? Sure. This will be a vertical major axis, so it would look like an ellipse standing up. Okay. You have a homework assignment. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 problems. Do not make me grouchy. It could be really nice. I'm in a good mood. Have you ever been in one of those rooms where you can stand in one certain spot and kind of like whisper, and then you hear it on the other side of the room?
Yeah.
They have one at the Capitol. It's called a whispering gallery. It's shaped, the ceiling is shaped elliptical, so then it bounces off, sound bounces and comes to the other focus. It's kind of cool.